Imagine trying to, like, force a watermelon through a standard garden hose. Eventually the pipe just isn't big enough for the distance. Welcome to the deep dive. Today we are unpacking a spec sheet for HDTV Supply's WolfPack 4K 60 HDMI Active Optical Cables. We're moving past the marketing jargon to understand why this specific cable is, well, a pretty fascinating feat of modern engineering for you.
Right, because pushing a massive, uncompressed 4K video signal through long copper wires is exactly like that watermelon problem. I mean, to transmit a 4K resolution image at 60 frames per second with high dynamic range, you're looking at a staggering 18 gigabits per second of bandwidth.
Which is just huge.
Yeah, it's massive. And over short distance, sure, copper handles that just fine. But stretch it out and you hit some really hard physical limitations. Manufacturers have to make the copper incredibly thick just to compensate for the signal loss.
Right, which leaves you with a really heavy, stiff cable to, like, route behind your walls.
Exactly. And crucially, a long copper wire basically acts like a giant antenna for electromagnetic interference, or EMI. Just absorbs all that outside electronic noise.
So if copper completely taps out over long distances, how does this WolfPack cable manage to stretch a perfect 4K signal up to 330 feet? Like, do they abandon copper entirely?
Well, no, and that's the clever compromise here. The secret to this cable is that it's a hybrid. They use plastic optical fiber to handle the heavy lifting of the video data.
Oh, so that's where an active optical cable comes from.
Right, there are actually tiny microchips embedded right inside the connectors. They instantly convert the electrical video signal into pulses of light, shoot it down the fiber, and then, just convert it back at the other end.
Wow. Okay, so the video is traveling via light, which completely bypasses that electromagnetic interference problem. But why keep it a hybrid then? I mean, why not just go 100% fiber?
Because your devices still need to talk to each other the old-fashioned way. The cable retains a few tiny, traditional copper wires alongside the fiber, specifically to handle the display data channel, or DDC.
Ah, the handshake.
Yes, exactly. That's essentially the data handshake that lets your TV tell your video player what resolutions it can handle, along with, like, basic control signals.
That makes total sense. Keep the copper for the simple translation work so it stays fully compatible with a standard HDMI port, but use the fiber for the massive video payload.
Wait, but if there are microchips converting electricity to light inside the connector, where is the power coming from?
Well, that's a huge benefit of this design.
Because usually active cables need like a bulky external power brick, right?
They do, yeah. Traditional copper repeaters need wall power for that heavy lifting because they're physically amplifying a degrading electrical voltage. But because this cable uses light, it only needs to power those tiny microlasers in the connectors.
Which probably doesn't take much. Hardly anything. It requires a microscopic 0.25 watts. It just draws that directly from the 5-volt pin already built into the standard HDMI port, so zero external power adapters needed.
That is incredibly slick. And because you strip away the thick shielding in those power bricks, you end up with some pretty wild physical specs. Like, looking at the sheet, it's only 0.16 inches in diameter.
Yeah, it's incredibly thin.
And a 330-foot run weighs under a pound. Yet, it says here it can survive a 100-kilogram crushing load. It's like an armored data highway disguised as a strand of spaghetti.
That is a perfect way to put it. And those specs dictate where this technology is actually deployed. I mean, yes, it's great for high-end home theaters, but its true value is in high-stakes environments.
Like the surgical theaters mentioned in the source.
Exactly. Because it's completely immune to electronic noise and incredibly durable, it becomes critical infrastructure in places like surgical theaters, manufacturing plants, or data centers, places where a dropped frame simply isn't an option.
Right, so ultimately, by blending fiber optics with copper, engineers have solved the modern data distance dilemma neatly and invisibly.
It really is a very elegant fix for the bandwidth limits we're hitting right now.
It does make you wonder, though, if we are already pushed to use fiber optic lasers just to get a 4K movie from our receiver to a TV 300 feet away, what kind of radical material science will our living rooms require when 8K or even uncompressed holograms become the standard?